Alright, hey guys, Mr. Yisley here. So we're on to lesson number 3, and we're still talking about how to find the greatest common factor of a list of terms, right? Now, before we dealt only with numbers, and that process will still be the same when we look at the numbers. But now as you're looking at these examples, you're probably noticing that they have variables involved as well. So we're going to talk about how we figure things out when there are variables involved as well with this. So when we do this, the first thing we do is we deal with the numbers. So on example A, I've got 12a squared, c squared, and 32ac to the third power. So I'm going to deal with the number first. So as I make these factor pair lists, right, I'm going to rewrite them, all right, down here just so I have a little bit more room. 12a squared, c squared, right, and 32ac to the third. And so I'm going to deal with the number first. So I'm going to deal with this number 12 first, and I'm going to list out all the factor pairs of 12. Starting with 1 and 12. Then I'm going to do 2. Does 2 go in? Yes, it does. 2 and 6. Does 3 go into 12? Yes, it does. 3 times 4. And 4 is already on my list, so my factor pair numbers are complete for 12. So then my next step is to deal with the a's. So a squared, as we've talked about before, means a times a. So we've got a times a. So I'm going to list out 2 a's there, each separately. Right? Then I'm going to deal with the next variable I have, which is c squared. Well, same idea, that means c times c. So I'm going to list out 2 c's. Now I'm going to go through and I'm going to do that exact same process for my 32ac to the third. So 32 is the number, so we start there. So 1 times 32 equals 32. 2 times 16 equals 32. 3 does not go into 32. Does 4 go into 32? Yes, it does. 4 times 8 equals 32. Does 5 go into 32? No, it doesn't. Does 6 go into 32? No, it doesn't. Does 7 go into 32? No, it doesn't. And 8 is already on our list, so we are done with the factor pairs of 32. So now I move on to my first variable, which is a. Now there is not a exponent listed, which we've learned means it's an exponent of 1, so really all I'm doing is just listing 1a. Then I need to move on to my c's, which is c to the third power, which means c times c times c. So I'm going to list out 3 c's. So what you're probably noticing is that the number tells you how many of the letter to list, right? And that's, of course, what exponents actually mean. That times itself that many times. All right, so now once we've got all of that information listed out, now we're going to go back to our smallest number, which in this case is 12, and we're going to start with the biggest number of it, which is 12, and check to see if it's on both lists. Now 12 is on this list, but it is not on that list, so that is not the greatest common factor. 6 is on this list, that's the next one in line, but it is not on that list, so it is not a greatest common factor. So move on to 4. 4 is on this list, and it's on this list. So 4 is the greatest common factor number. So if I were writing out my GCF, I would say 4 is the number that we're going to have, the coefficient. Then we're looking at the A's and going, what's the greatest amount of A's that's in both lists? It's got to be in both, not just in one. Well, I've got 1A here, right? And I've got 2 here, which means I can only use 1 for a greatest common factor. So I can only have 1A in my greatest common factor. Then again, we're looking at the C's, doing the same idea. What's the greatest amount that's in both? Well, this one has 2 and this has 3, so 2 would be the greatest amount of C's that we could have. So we would write C squared. So my greatest common factor is 4AC squared. And that's how we arrive at our greatest common factors when variables are involved. All right, well, let's go through example B again together, that same process. So I'm going to first write out my numbers, so my terms, which is 10x squared y. Create my little line. Then I've got 15x and z. 15xz. So again, start with the numbers 10. So 1 and 10, obviously. 2 times 5 equals 10. 3 doesn't go into 10. 4 doesn't go into 10 evenly. And 5 is already on our list, so we're done with the numbers. Then we move on to the x's. So I've got the x's here. Well, the x squared means x times x. And then I've got a y right here, so I'm going to write out my y down below because there's only one of them. Then we're going to do the same thing for 15. So 1 times 15. 2 does not go into 15. 3 does. 3 times 5. 4 does not go into 15, and 5 is already on the list, so numbers are complete. Then I see I have just a single x right here, so I'm going to list that out. I see that I also have a single z right here, so I'm going to list that out. So then we go back again to the smallest number of the two between 10 and 15, which is 10. We check to see if that's in both factor pair lists. It is not, so not a part of the greatest common factor. Move to the next number in the list, which is 5. Is 5 in both lists? Yes, it is. So my greatest common factor is going to involve 5. Then I'm looking at x's. Do I have x's in both lists? I do. What's the smallest amount of x's I have in a list? Well, it'd be this 1 right here, which means I can only use 1 right there. So x is there. Now I notice that I have a y in this list, but not in this list. So I can't have it as a greatest common factor because it's not in both lists. I also have a z in this list, but it's not in this list. So again, I can't have it as a part of my greatest common factor because it's not in both lists. So when I look at this and what I circled, I have a greatest common factor of 5x. All right. Well, I'd encourage you to try example C now on your own, then check your answer with mine. All right, well, example C, we've got 50xy, 80xy, and 10xy to the third. So again, create our list. This time we're going to have 3 lists because there's 3 terms. So 50xy, 80xy, and 10xy to the third. All right, so we'll start with the first list for 50xy. Start with the numbers. Well, 1 times 50, obviously. Does 2 go in? Yes, it does. 2 times 25. Does 3 go into 50? No, it doesn't. Does 4 go into 50? No, it doesn't. Does 5 go into 50? Yes, it does. 5 times 10. Does 6 go into 50? No, it doesn't. Does 7 go into 50? No, it doesn't. Does 8 go into 50? No, it doesn't. Does 9 go into 50? No, it doesn't. And 10 is on our list. So there's the complete factor pair list for 50. Now I see that here we've got an x here, but no exponent listed. So that means we only have one of those x's. I also see we have a y right there, but there's only one of them listed, or no exponent, which is an exponent of 1. So I'm just going to put a y there. Now I need to do the same process for the 80xy. So start with the factor pair list of the numbers, 1 and 80. Does 2 go in? Yes, it does. 2 times 40. Does 3 go into 80? No, it doesn't. Does 4 go into 80? Yes, it does. 4 times 20. Does 5 go into 80? Yes, it does. 5 times 16. Does 6 go into 80? No, it doesn't. Does 7 go into 80? No, it doesn't. Does 8 go into 80? Yes, it does. 8 and 10 times 10. Does 9 go into 80? No, it doesn't. And 10 is already on our list, so we're done with the numbers. Then I see that I've got a single x here, no exponent, so I'm going to list that x here below. I also see I have a single y right there, so I'm going to list that single y right below because there's no exponent listed. It's only one of them. Now I got to go on to my third list and do my numbers. So I've got a 10 here, so I'm going to start with 1 times 10. Does 2 go into 10? Yes, it does. 2 times 5. Does 3 go into 10? No, it doesn't. Does 4 go into 10? No, it doesn't. And 5 is on the list. So we're done with the numbers. So then I see I've got an x, no exponent. That means there's just one of them. So I'm going to list one x. Then I see I've got a y to the third, which again means y times y times y. So I'm going to list out 3 y's. And that's the end of that term. So now again we start with the number, and we start with the smallest number of the 3, which in this case would be 10, the last term that they gave us. And we start with the number 10 to see if it's on all 3 lists. So 10 is on, obviously, the 10 list. It's also on the 80 list, and it is also on the 50 list. So 10 is a part of the greatest common factor here. So then, once we are there, let me move that up. Sorry, I had one of the y's was cut off on the picture, I just realized. So then we go on to the variables. So I see that I have x's in all 3 lists, and I see that I actually only have 1 in all 3 lists. So that makes it pretty easy to determine the greatest common factor. It's just 1. But remember again, it's whatever the smallest amount of that variable is that's in all the lists. So then I see I have y's in every single list. So I've got 1 y here, 1 y here, and 3 here. But the smallest amount that's in all 3 lists is just one of them. So 1 here, and 1 there. So then to figure out my greatest common factor, I put that all together. So my greatest common factor is the number 10, 1x, and 1y. So greatest common factor is 10xy. All right, well, I'd encourage you to try example D on your own, then check your answer with mine. So example D, we've got 3 terms listed here, 21m to the 7th, so I'm going to write that down. Line underneath, 18m to the 6th, write that down, line underneath, and 45m to the 8th. Write that down, line underneath. And then go through and create our factor pairs list. So with 21, I know 1 and 21. 2 does not go into 21, but 3 does. 3 times 7 equals 21. 4 does not go into 21. 5 does not go into 21. 6 does not go into 21, and 7 is on my list. Then I've got m to the 7th. Well, that means m times itself 7 times. So I'm going to list out 7 m's. So 1, 2, 3, 4, 5, 6, 7. Whew, that's a lot of m's. Then I'm going to do the same thing now to create my list for 18m to the 6th. 1 times 18. 2 times 9 equals 18. 3 times 6 equals 18. 4 does not go into 18. 5 does not go into 18. And 6 is already on my list, so the numbers are complete. Now I've got m to the 6th, so that means I need to write out 6m. So 1, 2, 3, 4, 5, 6. So there we go, 6m's written out. Now I've got 45m to the 8th, so start with the number. 1 times 45. Now if you remember, we did this one earlier, so if you look up into your lesson number 2 notes, it's up there in example D, so you could copy it over. So 3 times 15 and 5 times 9. But again, if you don't remember that you had done it, you could go through the list. 2 doesn't go in, 4 doesn't go in, 6 doesn't go in, 7 doesn't go in, 8 doesn't go in, and 9's on our list, so we'd be done. I also see I have m to the 8th, so that means I need to list out 8 of these m's. 3, 4, 5, 6, 7, 8. And then again, start with the smallest number of the 3 on the list, which is 18, and see if 18 goes into all of them. 18 is on this list, but it's not on that list, and as soon as I recognize it's not on a list, it means it's not a part of the greatest common factor. Is 9 on all lists? So 9 is on this list, but it is not on that list, so even if it's on this one, which it is, it's not the greatest common factor because it's not on all 3 lists. 6 is 6 on all the lists? No, it's not. Is 3 on all the lists? 3 is here, 3 is here, and 3 is there. So 3 is the number that's on all 3 lists. So there's our greatest common factor for the number. Then what's the greatest amount of m's that I have in all 3 lists? Well, it's always going to be the smallest number of m's, which in this case 6, 7, 8 would be the 6th. So I'm going to circle 6 m's here, here, and here. So 6 m's. So when I go to do my greatest common factor, I know that my number is 3 out front, and my m's are m to the 6th. So my greatest common factor is 3m to the 6th. All right, well, this should give you everything you need to complete worksheet number 1 in the Chapter 6 worksheet packet. If you have any additional questions, please let me know. Otherwise, you have what you need to continue on to the worksheet.